We're in my lab looking at a hairdryer clamped to the tabletop in order to be a DC flow source. There's a cardboard adapter which allows it to adapt to an oval faceplate, which we had been using with a speaker attached here for AC flow. But again, today we're doing DC flow. Here's my scale. On the scale is the sled, just a plank in open air with some sidewalls on it, and it's placed so that the DC flow would come right over the top of the plank. And I have some additional boards here to inhibit a local downdraft. This is level, and they're not touching each other. You can see there's a slight gap here, and there's also at the face plate a gap here. So we'll zero this out and turn on the fan over here. I'll do just the fan at medium and then high settings. We're currently at 0 grams apparent mass, and now it's negative 1.8. On the high setting we're minus 4.4. And even if I remove these, it still seems pretty much the same. And we'll go back to the medium setting. And then off. Okay, now I'm going to take that sled and invert it so that flow will go underneath. Again, we have a slight gap there. We're zeroed out. Flow comes underneath now instead of on top. And let's go to DC flow again. So here's medium. That's a positive 3.7 grams. And high, 8.4. Back to medium. And then off. So we can see that DC flow, apparently, even in open air, is capable of both lift and inverse lift, depending on which side of a plank the flow is occurring over or under.